Welcome back again, Alex Louie, programming in Solidity. Let's talk about pure functions. Last video we talked about functions that were marked as view. In this video we're going to talk about pure functions. So pure functions are more strict than view. With pure functions, you're not allowed to modify state. So any function that you mark as pure, you cannot modify state with it. And not only that, you can't read from any state if you mark a function as pure. You're prevented from reading from state variables, and I'll give you an example on how to do this. And you can't call any function that's not marked as pure. So if you try and call a function that's marked as view, it's not going to work. Okay, you gotta call, if you want to call a function from a pure function, the other function that you call has to be pure. Let's take a look at an example here. So for me to write a pure function, first we say function, we'll call this pure func, returns, we'll just say uint. Okay. So, for example, if I was going to return any number, which is a state variable, not allowed to do that because it's marked as pure. And let's say I want to return, and again, I'm trying to read from a pure function, so that's not allowed. Let's say I try and say address my C equals this, so this gets the contract address for this particular contract. It gives me an address variable, gives me the value here, and even then I can't do this. It's gonna say function declared as pure, but this expression potentially reads from the environment or state, thus requires you can either be view or not marked as anything. So if I try and do return my C dot balance, again it's gonna mark both issues as an error. Okay, now you also have any global variables such as MSG, we have TX and block. These are blockchain variables, global variables. So message dot send or transfer, if you're trying to transfer ether, can't do it. Can't do it. So why would you use a pure function? Well, a pure function will be used in anything that you're gonna do a simple calculation on that doesn't require any type of state variables that need to be stored. You're just pretty much returning a calculation. So for example, if I was going to do function sum, and I mark this as pure, public returns uint. And within my function sum, I'll get rid of this, I'm going to pass in two variables, two uints, okay, A and B. Okay, so if I return A plus B, and again, this is very simple type of calculation function, but there may be other functions where you're trying to find if there's an overflow when you're trying to add two numbers, because remember uint max value is 256-bit, so you may have a library class where you would call it, and that particular library has a pure function that calculates if there's an overflow in the sum of two values. Or it may calculate some type of product or any calculation. So whatever you pass in, as long as you're not modifying state or you're not reading from state, even if you try and read from state, you're better off passing it as a parameter to your function and then get the value of that state. So for example, if I was going to write, calculate some state, right? I'm going to do that. And then I can also try and say uint temp is equal to any number. Okay, and then I can pass in temp and 2. Okay, so now you see that I have a copy of my my state variable in temp, and I can pass that temp into my function, which is marked as pure. So I'm not really reading directly from state, I'm reading from a copy of what was made. Okay, I'm reading from a copy of what was made. So this would work. This would work. So let's take a look at one more example where, if even in an array, if I try and even push a value, so state array dot push, doesn't even let me do that. Now, if that's because I have this Pragma experimental version 5. If I got rid of this, then it's just going to give me a warning. But again, you're better off starting to follow conventions, so that oh, actually it'll give me an error for this one. It says declared as pure. Okay, so it does give me an error for this. So as you saw previously, with views it gives you a warning, but with pure it will give you an error. So I'm sure that for the other view functions it's coming soon, so you're better off using this to be strict typecasting, so with functions. So basically that's what pure does. Okay, so pure, if you're looking for a use case for pure, it's if you're writing a library and you just want to do some calculation that does not involve any type of state variables or global variables, such as block, tx, message, anything to do with message.data, message.transfer, or this.balance, or the contract balance. So you're promising not to read from state, modify any state, or any of the global variables that I mentioned, which is block, tx, and msg. And then also, you obviously you cannot use any assembly language, inline assembly language, in your pure function. Okay, you can't do that in a pure function. Okay, so that's pretty simple for pure. Again, the more you start writing contracts and when you get to writing libraries, you'll appreciate more of the pure function. But for now, when we're writing one contract, you're not going to appreciate it as much, but you should be aware of it. Thanks for viewing my video. You want to contact me, email me at parttimeadjunct@gmail.com, or reach me out at www.parttimeadjunct, or catch me in Twitter handle parttimeadjunct. You can always tweet to me or follow me. Thanks, and happy coding.